My name is Grant Swanson. I'll be your host today, and we have with us Guru Chahal, Head of Product here at Avi Networks, and Ranga, our CTO.
Thanks, Grant. We've got a pretty tightly packed next 30 minutes or so today, but really the goal is, as Avi Networks, we've been working with a number of large-scale production environments for containers, and the goal is to take some of those learnings and share those with you. I'll go over about 4 or 5 slides real quick to set the context for microservices, set the context for what is the gap. Typically, when we take microservices like architectures and try and take those into production, and then really show you with a live demo with Ranga's help on how those gaps can be filled with Avi software. So just real quick, for those of you who are not aware of what we do, we are a Silicon Valley company. We've developed a software-defined application services fabric that provides service proxy functions like load balancing, application security functions, combined with real-time analytics for the applications that we sit in front of. So think of us as the application's best friend. We're sitting in front of all applications for our customers and providing security, keeping them available, keeping them highly performant, and allowing our customers to understand the end-user experience as they access those applications. We sell worldwide into large global 2,000 enterprises and service providers today. Today, I'm going to largely focus on how our architecture applies to microservices architectures and really what's driving that movement. In terms of the services that Avi provides, it's a very broad set of services across load balancing, security, visibility, and analytics, and combined with architectural benefits around central management, completely REST API. Our focus today is going to be largely around containers and microservices. That's the block on the left. But we also provide similar services for SDN environments, for OpenStack and private cloud environments, and we do this both on-premise as well as off-premise for hybrid environments that our enterprise customers are moving to as well. So having said that, let me just dig into what we have lined up for today. So we'll focus a lot on containers and microservices as the primary use case that we're going to be discussing today. It's for about 15, 20 years, there's been this notion of disaggregating large monolithic pieces of code into more independently manageable, scalable, upgradable pieces of code, and that manifested itself from monolithic applications to 3-tier applications, a couple of decades ago, and that went through really pervasively across application architectures. And about 10 or 15 years ago, we started really seeing a lot of interest in what was at the time called service-oriented architectures. They were not fully fleshed out and as crisply defined as microservices, as we'll discuss today, but the notion was the same. How do you take a monolithic application and fragment it into much more manageable, easily manageable, very agile components? And that whole movement has resulted in what we call microservices now. And if you look at one of the primary gurus of that space, Adrian Cockcroft, who does a lot of writing on microservices, he talks about microservices as loosely coupled service-oriented architectures with bounded context. And what that really means is, if I go to, say, Amazon.com, the website, there is the UI storefront, of course, but there's a catalog service on the back end. There's a service that logs me in. There's a service that provides the recommendations for me, Guru, specifically. There's another service that captures all my existing orders that are in flight and provides status on that. So that one request going into an Amazon.com actually results in these 40, 50, 60 quote-unquote applications, or what in this context are called microservices, getting called internally to generate all of that content and to produce that one web page that I see in front of me. The same thing happens at Twitter. The same thing happens at Facebook. The same thing happens in a number of web-scale properties today. And the reasons for that are simple. When you fragment a large monolithic application into much more smaller, manageable chunks, and you bound their context, you have well-defined interfaces between these two, then you can go into a single application, my catalog service on the right side, for instance, and you can rev it, you can upgrade it, downgrade it, you can make changes to it, you can scale it, there's a lot of flexibility in how you optimize the overall application deployment when you fragment it in that fashion. And one of the reasons why there's this tremendous resurgence in microservices architectures is because traditionally it has been harder to do. It is extremely hard to do if you're just operating in a bare metal environment. It has been relatively, slightly easier, but still relatively harder to do if all of your microservices are instantiated as VMs. But now with the rise of containers, this ability to fragment the application and in individual microservices have perhaps a few containers to several dozen to several hundred containers scaled up and down in real time. That ability has really driven microservices to the fore. And that's where the opportunity lies in bringing these web-scale principles and opportunities and bringing these into enterprise architectures, but that's also where some of the challenges lie. And the challenges are largely around the fact that when you have a few large applications, you can take a number of application services in the data center. How do you keep it secure? How do you discover each other? How do you load balance to it? How do you provide monitoring capabilities for that application? Those you can put boxes for, right? Because you have maybe 10 or 100 or 1,000 applications in your environment, and you can take a few boxes and you can run the traffic through those and provide these services. What happens when those 1,000 applications become 100,000 containers or 200,000 containers? How do you manage those at scale? And even at smaller scales, as applications get fragmented and the traffic goes primarily east-west rather than north-south, how do you secure, how do you discover these services, how do you scale them, how do you monitor the individual applications, the individual containers, and monitor the end-user experience? That's sort of the primary challenge. And this challenge manifests itself in real life when a developer that is using a Docker environment moves over into production or tries to take their application and roll that into production. And the first time you head into the data center and try and put this in production, you run into a significant challenge. And you're challenged by your security team, you're challenged by your availability team, you're challenged by your operations team. So as developers, we go out and we're interested in getting some compute, getting network connectivity. We pick our cloud or resource manager for containers. We pick our service schedulers like Mesos and Marathon, etc. for containers. And then the challenges that come back to us are how are we going to isolate and segment all of these services from each other? How are these services going to discover each other? How will I monitor these services? And how will I provide full layer 4 as well as layer 7 enterprise class load balancing and service proxy functionality across? And this is really what I'd like to focus on today, primarily through a demo. How do you provide all these services for large-scale production workloads with a single click? So Avi has taken our container services, our application services fabric, and developed a container services fabric in association with a number of container technologies so that we can provide production class services around security, providing micro-segmentation service, each container, providing layer 3 to layer 7 security, including DDoS detection and mitigation, including SSL encryption, including comprehensive layer 7 security policies, etc. We provide natively service discovery capabilities so that a service can continue to, one of these potentially hundreds or thousands of services running in the environment, each microservice can discover another microservice with as simple as a DNS call. We provide real-time application maps and application performance monitoring capabilities for the services that that are running in that container cluster. And of course, most importantly, we utilize our distributed architecture to provide service proxies for the workloads that are running. So how do we do this? We sit alongside container resource management and container scheduling technologies. The code that we're shipping today, that you can get your hands on today and try it out, is natively integrated with Mesos and Mesosphere DCOS. It provides the service proxy, service discovery, service visibility, micro-segmentation and comprehensive security, as well as auto-scaling functions out of the box. How do we do this? We utilize a distributed architecture, much like any of the other microservices or the microservices architectures that are enabling this revolution. So what we did a few years ago was we studied how data centers are architected around proxy functions like load balancing, and the reality was there was a very appliance-centric way of deploying these applications. We looked at the appliances, divided those up into the brain, which is the controller, that is the policy repository, that's the orchestration mechanism for the various services, and also the visibility and analytics engine. And we divided that and kept it separate from the actual service proxy. So that data plane function, think of it as a micro load balancer or a service proxy, can now be distributed across the standard x86 compute that is running inside the environment. And you can run it much like any other load balancer in your environment on an entire x86 server to get high performance load balancing. Or you can deploy it as VMs. And what today's webinar is about is that we are now enabling our customers to spin it up as containers as well, so that you can get distributed load balancing, distributed security, distributed monitoring capabilities for container fabrics at scale. So having covered the architecture, let's actually dig into what we're going to show you today. We will demo our Mesos and Marathon integration for you today. How we work in this environment is that our controller, what I showed you on the previous slide as the brains of the system, our controller gets pointed to a Mesos or Marathon, a Mesos cluster. The controller natively adds service engines to all the existing Mesos nodes that are running in the environment. These service engines are essentially service proxies that provide the load balancing functions. Once the AVI controller instantiates these service proxies, when the next application is added into this existing Mesos cluster through Marathon, for instance, we provide zero-touch, completely automated service proxy functions for those containers or microservices that are deployed in that environment. And on a runtime, ongoing basis, as new Mesos nodes are added, more capacity is added, we automatically spin up service engines to provide proxy functions for those Mesos nodes. Also, at runtime, if the performance requirements of individual microservices change, and instead of 4 containers, you need to up to 10, 20, 40, 400 containers to meet the SLAs for those microservices, AVI helps scale the backend microservices itself. It is constantly looking at the application response times, and within limits that an administrator can set, it can spin the containers up or down. So again, a distributed architecture, much like a Mesos, Marathon, Docker Swarm, Kubernetes, and other distributed architectures. 2 components, the controller and the actual proxy function that lives on every single node, with automation driven through a single point, which is the controller. So let's cut into the demo. We'll show you, Rang and I will work together and we'll show you very comprehensive demo for all the things we talked about today. We've got an existing 40+ node cluster here in our data center. You could have this cluster out in Amazon. You could scale it to several hundred nodes, if not several thousand nodes. Fundamentally, what we're going to show you doesn't change. It all scales automatically and natively. The first thing we'll do today is we'll actually take these 2 separate entities. We've got a Mesos cluster, and we've got an AVI controller. We will take the AVI controller and point it to the Mesos cluster, and that'll be a single REST API, a single JSON blob that we'll use to do this. The controller will at that point handle all initial provisioning, so it will spin up all the service engines on the existing Mesos nodes. This could be an existing Mesos node in production, so we don't disturb any of the existing microservices or applications. We deploy the service engines. The next thing we'll do today is we'll create a number of microservices. For today, we are going to pretend that we've got an application called photo.com, and when you go to photo.com, it actually makes calls inside into a number of other microservices. Each of the microservices consists of a number of containers. So we'll deploy all of that, and what you'll see is a zero-touch provisioning of proxy capabilities, service discovery capabilities, and security capabilities for all of those services. And then we'll generate traffic. We'll make it live. We'll send some traffic through the system, and we'll see what happens from an operational perspective and the kind of insights that the system can natively provide. And what I'd love for you to think about is how many different technologies, products that you would have to pull together and try and scale yourself to provide all of these different functions. And really, it's about one-click deployment. It's about immediate production-ready clusters rather than having to piecemeal together a number of technologies to provide the same functions. So with that, let me cut into the demo. You can see my screen already. We've got a very simple system. We've got in the front an AVI controller, and the controller is the UI that you see is essentially running in the browser. It's calling REST API, which rests on the controller. So it's a single point. The first-class citizen from a configuration perspective on the controller is always the REST API, but certainly the UI is executing REST APIs to the back end as well. And when Ranga just logged into the controller, what you saw in the controller was we have no existing service engines. The controller is just the brain in some sense. So we'll cut over real quick, and if I go, and I can see here on my dashboard I've got no applications. I can also go to my dashboard and look at the infrastructure component, and there are no service engines in my environment as well. So we'll go into real time and we'll see what happens next. Before we do that, let's take a look quickly at the Mesos cluster as well. I've got a number of Mesos nodes. Ranga, how many nodes would this be? Existing microservices, existing applications that we don't disturb. So this is a fully functional Mesos cluster in an environment that our developers are also using, right? Marathon is the scheduler in this environment that we're running, the scheduling framework that we're running on top, and we haven't yet instantiated in applications using this instance of Marathon yet. So that's our world as it looks like from your perspective right now. We also have Ranga for the demo today. Instead of having to create by hand, we have already written a short script that allows us to very quickly connect the controller to the Mesos cluster, and that's the yes here. So we press that. What you see here is really interesting. So it's a single REST API with a JSON blob that has all the information, and all that it's doing is, hey, Avi, here's my Mesos cloud, here's how you access it, and that's all the information that we had to give to the controller. This created inside the controller a concept called a cloud connector. And we use this concept very broadly for connecting with OpenStack, for connecting with AWS in the public cloud, for connecting with vCenter for just virtualized environment, or connecting with bare metal to just deploy as much like you would deploy a traditional load balancer. So that cloud connector goes in, it goes to the controller, now the controller is interacting with the underlying Mesos instance to discover all of the Mesos nodes that we showed you here. So these are about 40 plus nodes here, and if I go back to our system and refresh the screen, what you'll see is that over the next about minute or 2 minutes, what the controller is doing is it has discovered all the Mesos nodes, and it is bringing up a very, very highly performant but a small micro footprint proxy on each one of the nodes, and that's what I showed you in the picture earlier. And to give you a sense for how small that footprint is, we're talking about as little as 1 vCPU and 1 gig of memory that can drive several gig of throughput and terminate thousands of incoming SSL TPS connections if it has to. So extremely high performant footprint thanks to an architecture that removes the configuration, removes the policy management, removes all the control and management functions from the data plane, making the data plane extremely, extremely fast, extremely performant. So on the left side now, what you see is, Ranga, you think all of these are done?
All of these are created.
Perfect. So it didn't even take 2 minutes. In about a minute or so, we've created all of the proxies on an existing system, and the system is good to go. That was my step one. So now we are fully aware and in sync, and we will forever be in sync with the Mesos cluster. If you add more Mesos nodes at this point, we'll just automatically add more proxies. At this point, our next step was to go into Marathon and actually create the application. So that's the next thing we'll do. We'll create an application called photo.com, and this application consists of about 24 microservices. And those 24 microservices each consist of several containers each. And that's what's going on here. So we had a small script. It went to Marathon and requested Marathon to create several microservices. That's what's happening down here. Each one of these microservices consists of a certain number of containers, and all these tasks are running right now. This takes about 30 seconds to about a minute to complete. And in the meantime, I'm going to go to the controller. So here's the best part. You never saw us configure anything on the controller. And what the controller is doing in real time, let's go to what we call tree mode, which is much more interesting. So in real time, as the developer or the data center operator fed those applications into Marathon and said, please go and create this microservice, we're sitting there listening on the buses to understand exactly what request was made, how many containers are being spun up, on which hosts are they being spun up, and as these 4 containers at the top of my screen get spun up, we understand natively that these 4 containers are sitting here at 10, 136, 15, 123, 80, 80 on a particular physical node. These 4 belong to the accounts microservice. We create a pool with these 4 containers, and we create a VIP, a virtual IP or a virtual service out of these. So all of these proxy functions that you either have to do by hand or you have to fuse together a number of solutions to try and make this happen automatically happen in real time. And that's the thing that is quite frankly, from my perspective, the most remarkable. So from here on, every application, every microservice that you put in the environment, it automatically gets created. It automatically, a service proxy for that application automatically gets created. As more containers are added or removed, all of those adjustments are automatic, and the system is ready to be used. This microservice is good to go right now. So Ranga, are we done creating the microservices?
Yes, we are ready to start some traffic.
Perfect. Before we do that, let's go ahead and go into what we call a map view. And the map view really captures the overall communication between the clusters. So we know we deployed the photo.com app. So I'm going to go to the root of the tree, the north-south portion. So when I go to photo.com, where does the request land? It lands on photo.com, the first microservice. This is the UI portion. And then photo.com in turn goes back and talks to a number of other services to generate the content that are requested. So let's go ahead and do that. Shall we send some traffic? Mm-hmm. Great. What you'll see on the right side is we're sending some traffic. We're only talking to photo.com. As we do that, on the left side, the system is detecting the fact that a user came in, started talking to photo.com, made a request, and photo.com then internally went to a number of other services. It went to user photos then went to a few other services, and so on and so forth within the system. This is remarkable if you really think about it. We never had to define any relationships between these services. We never had to tell the system as to how they communicate with each other. In an instance, as traffic is flowing through these services, we're able to detect who's talking to who. We're able to detect the direction of that communication. Photo.com is making a call into invoices microservice, and we don't care how many underlying containers constitute invoices, the service itself. We don't care about that. So this entire chart we're able to very quickly in real time update. So you can see the health scores. We're capturing about somewhere between 500 to 1,000 data points and metrics for every single microservice that is running, including throughput, latency. Let's take a look at that. And we generate based on that a health score. So you very quickly understand how are my services doing. So I'm going to click on photo.com. What you see on these arrows right now is throughput. I could go ahead and overlay that with the requests, total requests, overall latency of this communication. So when something is running slow, I can very quickly detect as a request flows through the system which microservices need to be scaled or which microservices are running the slowest right now. So remarkable amount of visibility into latency, throughput, etc. within the entire system. So you can see all of that information just overlaid on the individual communication charts for this particular service. Now I want to show you something really interesting. We went over the entire application map, and the question is, what happens if you want to secure a particular service? So we talked about security. Ranga, you wanna let's pick a service, a communication that you feel. So actually, let's pretend at the beginning of time I deployed this application. That's right. And the system just automatically discovered who's talking to who. That's right. There was this learning phase in some sense. Mm-hmm. And after a couple of days, I come back and say, let's take a look. How's the system performing? And as part of that, I discover, you know what? I'm really not comfortable with service. Let's pick a service, Ranga. Dev test sales talking to PR.
Yeah. Thanks, yeah. So I picked a service called PR, and so as soon as I click secure on this, immediately it shows me all the services on the left that have never talked to PR, which I have automatically categorized as a blacklist. And then on the right, I have services that have previously talked to PR, and I have automatically categorized them into a whitelist.
Great. So we're not enforcing security right now, but making it much easier for me to assess who are the guys who are already talking to each other and what communications never happen. So if I have 100,000 of these microservice containers across maybe 10,000 microservices in my environment, but only 10 of them on a given day talk to me, then I don't have to parse through that large set of 10,000 microservices. I already have the 10 that talk to me on a daily basis.
That's right, Guru. You can just operationalize it right here, or you can tweak something saying, hey, the dev test microservice isn't allowed to talk to this application.
Yeah.
So I'm going to disallow it and operationalize that view of the world.
Okay, great. And I never have to configure IP addresses.
No IP addresses, no ports. You don't have to worry about what happens if new containers are created, existing containers go down, nothing. You just say app 1 is or is not allowed to talk to app 2.
No ACLs?
No ACL.
No IP address?
No IP address.
So awesome. And this is already enforced.
Yes.
So I can see, so not only did the system enforce this, but we can see that there is a service in my data center that is trying to talk to PR, and it shouldn't be doing that. So it's remarkably easy. Now we can zoom back all the way even to the application map, and it's remarkably easy to say, hey, what are all the services that are just going out across my data center? You'll see a bunch of these red arrows going out, and they're just trying to scan and talk to all the microservices in my environment. So this is full protection, and I guess that's what the blue circle around my PR service. It's a secure service. It's secured as a whitelist, and to configure that whitelist, all the system had to do was it was in this learning phase. It detected everything. I could just enforce that, or I could do custom enforcement just like you did by removing dev test. And at this point, dev test sales simply can't talk to the PR service. That's great. I think we should definitely take some questions as well. We've been going on for quite a while. I'm sure there's questions around everything that we showed. Let me do a couple of things real quick. We can always come back to the demo if needed, but I want to go in here and while we take the questions, leave this on, because one of the questions I'm sure we'll be getting is how do you get your hands on this? How difficult is it to try it? It is remarkably easy. You know, I can do it. You head over to tryavi.com. We've got kb.avinetworks.com. All the documentation there is completely open, as you might expect. Head over to tryavi.com. That you'll see on the next slide. And what you'll find there is you have a CloudFormation script that you can use in your AWS instance, and in as little as 10 minutes, you'll get a fully ready-to-use Mesosphere DCOS cluster. Ranga, how many nodes do we spin up? I think
you plug it in.
You plug it in, great. So and with Avi pre-installed and the same demo that we just did for you right here, all of that up and running in about 10 minutes. Feed in the first application. Proxy functions will all be instantiated. Service discovery, which we didn't get much time to go over today, will all be in place, and you will be able to protect those applications. You'll be able to go over the application maps, go over the communication, the application performance of individual applications, and things like, several things that we didn't even go into a lot of detail today. So, for instance, for those of you who have been tracking what we do, you can go into the photo.com service here, for instance, and instead of the application maps and stuff, you could very easily go into the logs and say, you know what, who's been coming into my system? These are individual logs for users that are coming into my system, the kind of device types they're using, how much time an individual connection took. So if you're ever curious which incoming calls are taking the most time to serve, you can do that. You can just search that here. If you're curious what are the average app response times, you can do that. If you want to have analytics on the kind of browsers, the kind of end-to-end timing, the kind of IP addresses coming in, the kind of locations people are coming in from, you can do all of that. So we won't get the time to dig into this level of detail today, but just tremendous amounts of visibility and analytics and insights into who's using the system, what are they doing with it, are they having a good day or a bad day as they interact with your applications, and or are they a bad actor and are they trying to do something really, really bad?
Thank you, Guru. Thank you, Ranga. That was an incredibly informative and compelling demo. We have a few questions coming in from our attendees. The first question is, what is the footprint and performance of the Avi service engine?
That's a great question and a really important one, Grant. So as you see, this is a distributed architecture. That service proxy lives on every single node. So it's extremely important not to do the lazy approach. The lazy approach is you've got an existing load balancer, or you're in the load balancing business. You take your hardware load balancer about 5 years ago, you took that and crammed it into a VM and made a virtual load balancer, and now you take the same thing, all of it, and you could jam it into a container with a very high footprint. That just doesn't work. So what we did was, our service engines are extremely high performance and small footprint. We almost call them micro load balancers in this instance. And they can be instantiated on as little as 1 vCPU and 1 gig of memory, and actually if there's over provisioning, it's a fractional vCPU, fractional core if you really think about it. So extremely high performant, extremely small footprint, unlike anything that you would find in the traditional sort of a proxy or load balancing market.
Typically what we find, Guru, is that the north-south or the front-end SCs have to be multiple cores in order to be able to do things like SSL termination. The east-west can be very, very small as a single core using a single gig of RAM.
That's a great, it's a great thing. We didn't get to talk about this today, but you don't need a separate load balancer for that initial traffic that was going into photo.com, that north-south traffic, and then a separate solution for the east-west traffic internally within the cluster. The same Avi controller can spin up all the service engines that we showed you today for all the east-west communication. And you can take, if you really wanted to, you can take an entire service engine and spin it up in an entire 2 or 4 socket physical server for tens of gigs of, or hundreds of gigs of throughput, hundreds of thousands of connections terminated, extremely high performance load balancing for that north-south traffic, and extremely efficient distributed load balancing for that east-west traffic without having to manage those as 2 separate entities. So you're going to the same controller, all the visibility, all the analytics, all the policies are still centralized. Any other questions?
Yes, thank you. You mentioned autoscale, and is this just reactive, or can it be predictive as well?
Oh, there is both, and both of those things are built into the system. So what is reactive? Reactive means you saw us capture the latency for application response times for each microservice. So reactive means the response time was 10 milliseconds, and now it's shot up to 300 milliseconds, which is unacceptable, and we will go back into Marathon or your scheduling framework and just spin up more containers. And we'll go from 4 containers to 10 to 40 to whatever limit you set to ensure that the service response time is within limits. That's reactive. We do one better. Because we're also a learning system, and there's a machine learning system internally within the controller that is doing auto thresholding, it understands natively that every Monday morning at 7 a.m., the load on your application goes up. And once it understands that after a week or two, the subsequent week, Monday 7 a.m., maybe at 6 a.m., maybe at 6:30 a.m., it'll just automatically spin up a few additional containers to make sure that you're already ready to handle that. So after a while, as we've learned what's going on in your environment, the system is not just reactive for any net new things that happen, but also predictive, where it is looking ahead and saying, I expect the load on your system to move in this direction, and I'm going to respond to it right now.
Excellent. Thank you very much. We have one other question here. We have an attendee asking, how do you handle complex service additions, such as content switching?
So we are a fully functional enterprise class load balancer. What does that really mean? That means it's not just layer 4 load balancing. It's not just basic HTTP load balancing. You get all of the features we talked about very early at the beginning of the presentation. You get certainly layer 4 and layer 7 load balancing, but you get content switching, you get content acceleration, compression, caching, multiplexing incoming TCP connections, you get advanced security, layer 7 rules. You can have complicated rules, Grant, like if you're Grant and you're coming in from Europe, you're not allowed to access resource X. And you can have these extremely comprehensive and granular rules. So you can do coarse granularity security, like what Ranga showed you with the whitelist and blacklist for microservices, and you can do extremely granular. You can do DDoS detection, DDoS mitigation, and all of these advanced functions. So everything you would expect from a world-class service proxy fabric, we provide all of those services for all the east-west services as well as north-south services.
Excellent. Thank you very much. If anyone else has any questions, you can send them to grant@avinetworks.com or guru@avinetworks.com. Thank you very much, Guru and Ranga. We also are recording this webinar, so we will send the recording either later today or early tomorrow. Thank you very much.
Grant, before we let the team go, I'll make just a couple of quick points. There's always this question we get sometimes is, how much does this cost? Can I try this out? And I want to encourage everybody to download the code and try it out. It is absolutely free, not short-term free, not 30 days free, not 60 days free. It is absolutely free for you to use for dev test environments, for development, for test environments. And if you're a startup or a small company that is just getting started right now, and you're less than about 100 employees or so, again, the system is free to use for startups. So I would highly encourage you, and of course, we are very accessible. You can reach out to our community portal or send us questions if you have any, if we can help with any additional details.
Excellent. Thank you very much, Guru.
All right. Thanks for having us. Thanks, Ranga.
Thank you.
Okay. Bye.